Hello friends, welcome to my channel. Let's have a look at problem 2567, minimum score by changing two elements. In this video, we're going to explain a solution based on thought and check. Actually, for this problem, the reasoning is more important than the coding itself. First, let's roughly look at the problem statement. So we are given a zero-indexed integer array called nums. So here it defines the low score, high score, and the score. So the low score basically is the minimum absolute difference of two elements in the list, and the high score is the largest absolute difference. So the score of the list is the sum of the high and low scores. So we want to minimize the score of nums. So here we are allowed to change the values of at most two elements of nums. So we are required to return the minimum possible score after changing the value of at most two elements of nums. So here this means absolute value. So here we have two examples. So the first example is very special because we allow at most two changes, but this has only three elements. Basically, we can make them the same, so the output is 0. So for the second example, the output is 3. So here is an explanation, but this configurations or changes are not unique. So you're going to see this in our analysis. So the constraints for this problem are the following. First, the list nums has a length in between 3 and 10 to the power 5, both ends inclusive. And the elements in the list are in between 1 and 10 to the power 9. So the first one actually quantifies the problem size, and the second one is not that essential for this problem. So with that said, we are ready to do the analysis. So for the analysis, we are going to use thought and check. Basically, it's some mathematical reasoning. So here the observation is that we could always make the low to be 0 and then minimize the high. Then the high will be the score. So here the thing is that after sorting, the high will be the last element minus the first element at index 0 if we do not do any changes. So in order to fix the idea, I'm going to assume that the array is A. So we have A0, A1, A2, AN3, AN2, and AN-1. In other words, this is a less n array indexed with 0 indexed. So essentially, there are three possibilities. So the first possibility is to set A0 to be the last element, or the last element to be A0. So this gives the minimal score A-2 minus A1, right? So this, because this one is less than this n minus 1 minus A1, right? So this is the smaller one. This is the one possibility. Another possibility is that we set A0 equals A1 or add A1 equals A0. So overall, then to some proper value, right? So here is value. So say A-1. So this gives minimal score A-1, the last element, minus the third element or element with index 2. The reason is that this value is less than or equal to A-1 minus A1, because A2 is near to A1. And the third one is that third possibility, we set A, the last element, equals the second to last element, or an add reverse. So this gives a minimal score A-3 minus A0. So these are all possibilities of the possible minimal scores. So, but the set of the values are not unique. So we are going to return the minimum of the above three cases. That's all for the coding. But for this problem, I guess the most important thing is to gain the intuition or digest the logic. So here I'm going to use example 2 as a walkthrough first. So this is a nums. So this is the 14785. So I'll denote it as A. So after sort, we're going to get this one, right? In this problem, the gaps, you can consider the gaps. So here 3 and 1 and 4 has a gap 3, 4 and 5 has gap 1, 5 and 7 has a gap 2, and this has a gap 1. So in this example, if you know some statistics, this means this problem or probability, the small gaps are in the tail here. So in this example, I'm going to set A0 equals A1 and equals 8. So in this case, 1 and 4 are changed to be 8. So we have 5, 7, and 3, 8. And then because we have two equal elements, so the low score will always be 0, right? We will assume this. And then the largest one is 8, and the smallest one is 5 after the reset. And then we're going to get 3, right? So this is the example. But as we mentioned, the reset is not unique. So for example, A0, A1, we can set it to be 8, or we can set it to be 7 or 6, whatever we like. So in this example, we use 2 operations or 2 resets. So again, we mentioned that the choices or the resets method are not unique. So now also I would like to give a walkthrough for example 1. So this example is very special because we have 3 elements. So but we allow 2 resets. So we can make them all of the numbers to be the same. So this the score must be 0. So this is the second walkthrough. So here also I cook up an example. So this is the 1, 4, 7. Similar here, but I have 20 and 200. So different from the walkthrough in item A. So the larger gaps for this one are in the tails, right? So here, this is 180, right? This is 3. Or I use 20 and 200 to amplify the gap in order to make it more clear. And then after this is also in sorted order already, right? So for this one, we can modify the tail elements. For example, we can modify this 2 element to make it equals to 7, right? Or we can make it to 1. So because the modifications are not unique, or other good values as you like. So the score, because we have elements that are equal, so the low is 0. So we just need to focus on high. Because the largest value of reset, let's say, is 7. So it's 7 minus the smallest one is 1. So we get 6 for this example. So with that said, I guess we are ready to do the coding. So for the coding, so it's actually nothing special now. So here, let me first do a sort. And then we're going to do the return. So there are 3 possibilities. We just need to return the minimum. So first one is nums -2. So we just follow here, right? Follow this 3. Nums to -2 minus nums 1. And then nums -1 minus nums 2. And then nums -3 minus nums 0. So this expression is meaningful because the length of the list nums is bounded below by 3. In other words, we have at least 3 elements. So with that said, I guess this forms a format of a solution to this problem. Let me do a check. Yeah, it passes the example we cooked up. Now let's look at the generic case. Yeah, it passes all the test cases. So that's about it basically for this problem. As we mentioned at the very beginning, so for this problem, so the coding is not that essential. The thing is the logic or digest of the reasoning. So with that said, I guess that's about it for this video. You are welcome to follow up in my YouTube channel to practice more problems and other algorithms. With that said, I guess that's it for this video. Thank you.